Hi class, this is Dr. Selby here, and in this lesson I am going to show you how to balance chemical equations. In this first equation, we are starting off with hydrocarbon and reacting it with oxygen to produce carbon dioxide and water. This is an example of complete combustion. Whenever I balance combustion equations, it's easier for me to always start with carbon. And so that's what I'm going to do here. So here we have two carbons. We know that because of the subscript. And here there is no subscript, so it's an assumed one. So we only have one carbon. So I'm going to try putting a 2 here. Now, in combustion reactions, I do carbon first and hydrogen second. So then I'm going to try hydrogen. And here I have 6 hydrogens. And here I have 2 hydrogens. So if I multiply this by 3, then I will have 6 hydrogens. Then I always do oxygen last. And looking at oxygens, we have this 2 times this 2 here. So that's 4 oxygens there. Plus we have this 3 times this assumed 1 here. And this equals a total of 7 oxygens. And notice that's an odd number. And the only place we can put a coefficient is in front of this O2. Well, because that's even, no matter what we multiply it by, we're always going to get the result of an even number, unless we do kind of a baby step and multiply by a fraction. So I'm going to multiply this by 7/2. And I need to get rid of that fraction. And to do that, I'm going to multiply this entire equation by 2. So then I have 2C2H6 plus 7O2 goes to 4CO2 plus 6H2O. So that's my final answer, but I'm going to double check my work. So looking at the reactants, we see in the reactants we have 2 times 2 equals 4 carbons. And then looking at the products, we have this 4 times 1 equals 4 carbons in the products. For hydrogens, we have this 2 times 6 equals 12 in the reactants. And for hydrogens, we have 6 times 2 equals 12 in the products. And then last we have oxygen. We have 7 here times 2 is 14 in the reactants. And we have 6 times 1 is 6 there. And then we have this 4 times 2, so plus 8 equals 14 in the products. So this is indeed a balanced equation. Let's look at another example. In this example, I'm looking at the reaction of iron plus oxygen to form iron 3 oxide. And in this problem, I'm going to start with looking at oxygen. So there I have 3 oxygens, and here I have 2 oxygens. And the lowest common multiple between 2 and 3 is 6. So I'm going to try putting a 3 here for a total of 6 O's, and a 2 here for a total of 6 O's. And then I'm going to move on to iron. Here I have for iron, I have a 2 times this coefficient, which is 2, which gives me 4 in the product, so I would like 4 in the reactants. And that is a balanced equation, but let's just double check our work. So looking at our oxygens, we have the 3 times 2 equals 6 in the reactants, and this 2 times this 3 equals 6 O's in the products. And then for our irons, we have 4 times 1 is 4 in the reactants, and here we have this 2 times this 2 down here, which equals 4 in the product. So that is a balanced equation. Let's look at another example. In this example, I'm looking at a reaction that occurs with both of the reactants in solution. So dissolve some magnesium nitrate in water in one container, dissolve some sodium carbonate in water in another container, and then we're mixing them together. And so this all occurs in aqueous solution. And we noticed that we have polyatomic ions here. So we have nitrate there, we have nitrate here, and we have a carbonate here and a carbonate here. And when you're balancing problems like this, and this is a precipitation reaction, I always recommend to my students is to keep those polyatomics grouped and balance them as a group if they appear in the reactants, how they appear in the products, and in this case they do. So where do I start? In this case, I'm going to just try to start with my carbonates. So here I have one carbonate group, and here I have one carbonate group. Okay, that's already balanced, nothing to do there. Let's look at sodium. For here I have two sodiums, and in the products I only have one sodium. So I'm going to try putting a 2 there. Okay, so that I can move on to nitrate. So I have 2 times this entire group. That's 2 nitrates in the products. And I have this 2 means I have 2 nitrates in the reactants. So now let's look at magnesium. I have 1 magnesium in the reactants. I have 1 in the products. So this is balanced. And let me clean this up for you a little bit. So really all we had to do here was put a 2 in front of the sodium nitrate in the products. And we always double check our work. And again, we have 1 magnesium in the reactants and 1 magnesium in the products. We have 2 nitrates in the reactants, 2 there. And we have this 2 times 1 equals 2 here. Looking at carbonate, we have 1 in the reactants and we have 1 in the products. So 1, 1. And then sodium, we have 2 in the reactants, and then the 2 times 1 equals 2, so 2 in the products. So that is indeed a balanced equation. Let's look at one more precipitation reaction example. In this example, it's another example of a precipitation reaction where I'm taking an aqueous solution of lead 2 nitrate, making in that one container, and then in a different container, I have an aqueous solution of potassium phosphate. And then what I'm going to do is mix those reactants together into the same container, and then a chemical reaction will occur. Okay, so again, let's just point out these polyatomic ions. We have a phosphate group in the reactants and phosphate group in the products. So we're going to leave those phosphates grouped together. And we also have a nitrate group in the reactants and nitrate group in the products. So we're going to keep those together. Where should I start here? I think I'm going to start with this lead. There's a 3. So there's 3 leads in the product. So I'm just going to try putting a 3 here. Then what do I want to look at? I noticed that there's a 2 here for the phosphate group. So I'm going to try putting a 2 here. So here we have 1 phosphate group. So if I multiply 2 by that whole formula, then we would have 2 there. So let's see where we're at. This gives us 2 times 3 equals 6 potassiums in the reactants. And looking at the products, we only have 1. So I'm going to try putting a 6 here. And that should give me a balanced equation. I want to clean up some of my markings. And this is our balanced equation. Then I want to check everything. So I have 3 leads here and 3 leads there. So this is 3, 3. That's balanced. I have a total of this 2 is for the nitrates, but we multiply by 3. That means we have 6 nitrates in the reactants. And then this 6 times this 1 nitrate group here would be 6 nitrates in the products. We have 2 times 3 equals 6 potassium in the reactants. And this 6 times 1 is 6 potassium in the products. And then our phosphates, we have 2 times 1 phosphate group is 2 in the reactants. And then that 2 there is for the whole phosphate group because it's in parentheses. So we have 2 in the products. And that is a balanced equation. This is the last example in this short micro lesson. If you have any questions, please let me know. Thank you and have a great day.